created my own little algorithms to do one thing or another, like disease states, a mortality algorithm. And
I think you will have a whole levels of robotics, like humanoid robots or non-humanoid robots, whatever the case is.
But the one that I really gravitated towards was Alteryx. Low code, no code, business intelligence stuff, data science, machine learning, things like that.
Audio, the text, and then there's big metaverse stuff. Everybody knows the metaverse.
Another week of AI.
All right, live.
All right, let's go. Welcome back to the III podcast. With this episode, we're going to talk about semiconductor chips, those tiny brains inside electronics, and AI agents, your digital assistants. So we have amazing people on today, Keyshawn and Dr. Drew, along with Asif and Lucky. Let's get into it, y'all.
If we have to start, first of all, we got to start with why we're here, right? Then slowly we're going to get into how and what, somebody like Masako is the reason we're here, right? Because we are all advocating for something that we believe in. Masako has her, passion behind a few things that she represents. We all have our own passions. We all have our own cause in life that we say, you know what? There's so many things in life we can do, but let's get together on a podcast and tell the whole world about it. Why not, right? So thank you all for joining. This really is an exciting opportunity to continue the same conversations that we've been having, I guess, 78 episodes ago, where we're talking about people, process, and technology, right? We want to identify the people, let them know who they are, figure out what sort of process they need, and how technology serves them very, very well, right, through that process. So this piece of people, process, and technology is an age-old problem. But as you can tell with AI, with semiconductor chips, with the way we are able to develop software, it's taken off, right? It's taken off. This process is continuously shifting, but people on one hand is not really shifting with it. And that's a age-old problem we always had. People, process, and technology. Process moves rapidly. Technology moves with it. But people have to have some time to pick up and catch up with it. And this is how it starts. It starts with the conversation. It starts with some awareness, some education. And if we have to identify a few things about what needs to be what needs to become education for people, it's the hardware, software, and data. Easy as that. If you don't know enough about hardware, we got somebody here talking about hardware. And if you want to know something specifically about data, we got somebody here about data, right? And of course, Lucky, the cybersecurity guru, is here as well. We're going to cover multiple aspects. And today, I'm just super thrilled to introduce my good friend Keyshawn, who's been a mentor, kind of like a North Star, right? And tell me hey, go here, right? And not for me only, he does it for a whole community called Dallas, right? Dallas Bunker Labs. A lot of military veterans have been through Dallas Bunker Labs, and he mentored many of us, right? And I would say 5 years ago, he was that one person kind of said, we're going to have Dallas Bunker Labs, and we're going to help as many entrepreneurs as possible. And through that, I'm one of the entrepreneurs that said, you know what? I can do this. With people like Keyshawn, anything is possible, right? So Keyshawn, sir, welcome to IIIAI podcast.
Thank you. I'm glad to be here with such astounding individuals. I know I'm going to learn a lot from you all today. So I got my pen and notepad ready, and let's get into it.
Well, you're going to get started, but before you get started, sir, you got to hear the chants, because we don't call it IIIAI podcast we call it IIIAI podcast for obvious reasons. And Lucky is the reason for it. So Lucky, how you feeling, brother? How's your vocal cords doing?
I'm feeling great. I'm feeling even better now that we have this group together, and it makes me feel like but really, building on what you guys have already covered, there's a lot of reasons why we should use AI and how we can benefit from it. So a lot of people just don't know, what AI. They just think, well, just get me that AI, and then we'll be okay. But we'll cover, what is really necessary and what's realistic. So thank you all for being here today, and we can help paint that picture. So welcome.
Yeah, absolutely. And we also have Dr. Drew Minkin with us, right? Returning champion. Last time we had this discussion, it was a heavy knowledge sharing, right? A lot of in-depth understanding of what it is that we need to know. But this is what we do in this podcast. We invite everybody in and have them learn something new. And this is a learning session, I would say. So, Dr. Drew, I know you have a specific chant to go with, but welcome back, sir. And I'm looking forward to that chant.
All right. Well, I'll give it a try. I mean, I got to do it I got to do it my way because Lucky's hard to keep up with. But there we go.
There you go.
That's a lot of tea right there to keep that going. Basako, you're not excluded, and Keyshawn, you're not excluded either. You're welcome to give it a shot.
I think that's all I get.
I got that late day vocal coffee. Now we can get going.
Now we can keep going.
If I wanted to be more like my Jewish ancestors on my father's side, it'd be ay.
And now we have Bobby with us as well.
Hey everybody, how y'all doing today?
Bobby?
Hey, Bobby Ray.
Good to see you.
Bobby said, "I'm not gonna miss my ay chant today. I'm gonna join right on time."
Right.
Hit it, Bobby Ray. Give it your
Come on,
ay.
Bobby, hit it one time, please.
Ay.
There you go.
All right.
We're all in now.
Yeah, this is a full house. I'm glad that everybody's here now, and we can get started with everything we need to talk about to anybody who's listening, right? But we definitely want to talk about something in an early stage to set the stage for what the rest of the conversation will look like. Because none of this conversation will happen without the hardware. And that's the most hidden aspect of all the discussions around artificial intelligence is the hardware. Once people find out about the intricacies of this hardware, the infrastructure behind it, it really is just important that we all get to see the familiarity of how these hardwares are placed and how they work and what do we need to know about them. So, Keyshawn, brother, I really want to hear everything you have to say about the hardware and some more, but give us some high level, maybe a 10,000 foot view of what it is that you see and what it is that you think we should know about.
Yeah, absolutely. So just to give the audience a little bit more background context about me. So I've been working in the AI space at a large technology company for about the last 6 years. And half of my tenure there, I've been working specifically in data centers. So building out data centers, installing H100 chips, and doing AI. I think one of the biggest challenge we have today is, when people think AI, they just think software. And kind of in my world, it's kind of saying like, how do you move up the stack, right? So you have the actual physical hardware. Then on the hardware, you have some type of software that sits on top. And then whatever sits on top of the software is where you truly start to see like the AI agents, the LLMs, all the intricacies of what we call AI. But if we move down the stack to the actual base of it, it all starts with infrastructure. So to any veteran that's out there, any individuals that's looking to move in the space, I truly feel there's a huge opportunity what's currently happening in the market right now. And so if we look at a data center, right, because I think that's most people be like, well, where does all of this hardware sit, right? So where do these AI agents that, live in this weird ether that, we never see, we never touch outside of a computer screen, like where is all of that happening? All that happens at a data center. So you have different activities that can happen. You have on-prem. Some companies have their own physical infrastructure physically on their site. And then you have cloud. So the space I worked in is in the cloud space. So cloud GPUs. And what happens at a data center is essentially this. I like to say from dirt to GPU. When you're building out the data center, things you have to consider is power and cooling. These machines run extremely hot. So think like your car, right? You're never going to take your car to the Sahara Desert, take all the coolant out the engine and just run it as hard as you can. The engine is going to die almost instantly. So with these GPUs that you have in data centers, you have to have some type of cooling mechanism to take the heat off of the chipset and kind of recycle it through the machine. A lot of data centers that we're seeing in today are moving to more eco-friendly, where they're actually repurposing a lot of the heat that comes off the GPU chipset. So there are systems whereby you can capture that heat and actually repurpose it within the building itself. So I worked at a data center in Canada where they were actually repurposing some of that heat back into the building that were coming off of the GPU chipsets. And then within the actual data center itself, you also have power, right? So think of your home. Your home is connected to an electricity grid. That electricity grid is connected to like a major substation that's kind of providing your community power. So think of that exact same concept at a data center. When the power comes into the data center, it goes through this mythical transformer that helps kind of convert the power down to think like clean energy so it can actually go to the GPU racks. When it gets to the GPU racks, all that power is then broken up to each of the different servers, right? So on the servers, you have what's called rear door heat exchangers. I know that sounds like a big fancy word. It's just a big word to say a big air condition. So when you have all this power going in, you have all this heat being generated, you have to have a way to kind of pull off that heat off of the chipsets. So you have what's called a rear door heat exchange. And it looks exactly like it sounds. There's a big door that has a bunch of cooling fans, and you put it on the back of a rack where all your different servers or your physical infrastructure sits on. And that helps also pull some of the air out or some of the hot air out. So there's two types of chipsets that you have. You have liquid cooled, which basically means you have this special type of water that passes through the machines to help keep the chips cool. And you have air cooled. Air cooled essentially means that the room itself is at a cold temperature. And it's basically using like a big air condition to help keep all the machines cool and running. Within that, you have your CPUs, which if you know even the basics about computers, you have your processing units that sits on the actual chips. You also have like storage. So if you think about your phone, you have all your photos saved somewhere. So each of these different servers have storage. They have CPUs. They have the GPUs that sit on there, which makes the physical infrastructure itself. Now, once you have the physical infrastructure, you have to connect it all, right? So how do you best talk to each other? There's cables, thousands and thousands of cables in a data center. So you can have all these isolated components, but if they can't talk to each other, it does it no good. So we have thousands of cables that are going back and forth. Think like spaghetti noodles that are connecting each of these machines together so that they can speak one language. Now, we talked about moving up and down the stack. So once you have the physical infrastructure, you have the software that sits on top of it. And then you have the internet that kind of comes into it to say, hey, how do you access Netflix, right? You got to have the internet. So if you want to go download a movie, you're connecting to a data center somewhere in the world that is processing that information so that you can have kind of access to it. So I know I was kind of hodgepodge, kind of like all over the place, trying to give you like everything I know of a data dump in like 65 seconds, but I'm happy to peel the onion in any of those directions.
Yeah, I mean, this is where the peeling the onion starts right here, right? Because what you mentioned, if people don't see how that makes the whole globe work, right? They're not going to get interested because this is just off of that sort of an importance that we have these sort of knowledge and these sort of infrastructure to be a global lead in whatever. Innovation, national security, whatever you can think of, it's all related to these bare metal boxes that we're discussing, right? And if you go dive deeper and deeper into it, it's not about just, I love coding. That's why I'm in IT space. No. This is beyond coding. This is science. This is atomic level deposition where 15 atoms side by side creates a gate. And through that gate travels these electricity, the volt that he's talking about. And if you want to dive deep into it, it's like Lego. Yep. If you don't have all your Lego pieces together, no data will flow. And if the data doesn't flow, there is no pickup, there is no drop off. And Keyshawn mentioned it very articulately with the fan, how that fan has to keep the heats out, keep the machine cool. So that way the system is not frying itself. Because we all know what happens when a Samsung phone and its battery blows up. You don't get to fly no more. PPA, it's the terminology that I will highly recommend everybody Google it and see how PPA plays out, which is performance, power, and area. And if you look at this area, since 1950s, when we had the first AI, that processing area with performance of it has been shrinking tremendously. So when we're talking about shrinking something that you can see, all of a sudden you don't see anymore, because it's a size of about 15 atoms sitting side by side. Atoms. I'm talking about like things that people cannot even put microscope on. That's how small it is, because once you go atom less, you end up in a quantum space. And of course, we all know about quantum computing. So here's my challenge to anybody and everybody who's listening. Do the research and see where it is that you fit in, because you do not have to be an IT person. You can be that guy who loves to work in cars, go under the hood, and break the engines apart and put them together. And if you want to do it more of that, but with some atomic level depositions, you want to start looking into semiconductor chips and, of course, these hardwares that Keyshawn just mentioned very, very well. So I guess here's my next question to you, Keyshawn, because we are talking about jobs and how job market is changing, how the employment is changing. Because if I speak on it, I speak on it usually from the perspective of manufacturing chips in Texas, manufacturing chips in our neighborhood, literally in our neighborhood, because Austin, Sherman, all these areas is where the fabs are. That's where they manufacture chips. But as far as data center goes, that's a whole nother job that we have to discover, because, okay, yeah, you got semiconductor chips manufacturing, but these chips will end up in the data center. The reason they're manufacturing them is to have them in the data centers, these GPUs and CPUs. So walk us through like these maybe not necessarily just job, but the business opportunities that's out there, because there's a whole lot of services that shifts the whole supply chain from the global to within few cities within Texas.
Yeah.
And all these are shifting.
Yeah, absolutely. You stated very well. Like there's an entire ecosystem that happens when it comes to AI. There's the physical, there's the raw material to build the chips, right? And then if you travel further down the ecosystem, then there's the physical data center. I think anytime you open your phone to Yahoo or Google News, there's always a story of AI. Facebook is building another $6 billion of data centers in Minnesota, right? Cold climates are ideally the best, just FYI. Or you'll see Google is building a data center in South Texas, or, Twitter is building one in XYZ. Like there is not enough data center capacity. And when I say capacity, that means like there's not enough physical infrastructure of buildings for racks to actually go sit in. So if I was a veteran and I'm like, hey, how can I leverage this and leverage my skill set? Let you all know, I do not have an engineering background. I'm great at project management. I'm a PMO. And so I stepped into the AI space, leveraging my PMO project managing skills. And I learned AI from the ground floor, literally plugging in cables into the back of servers, opening them up, changing out GPUs, CPUs, all that things. So if you do not feel as comfortable in the coding world, there's an entire another world where you can still be involved. And that's helping building out this capacity in the data center. So even if you got a trade as an electrician or a plumber, I am telling you right now, there is not enough of these individuals at data centers, and they are making money hand over fist. So if you wanted to start a business as a subcontractor for plumbing, electrician, security, there's not enough of these specialties out there to where there's a few players in the market that are repeat customers because they just know how to churn. They know the faucet's open and they're going to take as much water from it as they potentially can. And the more cups that come in, the better competition there is, the better pricing will be. But there is a huge market opportunity out there for that.
Yeah, you mentioned that. Can you guys hear me okay? Yeah, and it's really hot in the news, what it takes to build an AI. Like recently, you've seen a lot of with XAI and Grok, right?
Yeah.
What it took to build the facility in Memphis. And do you have any insight on, the power and what it took to bring up something like that?
Yeah. So let's just think about like for 2,048 GPUs. So if we break it down to a level lower, each server, right, they consider it a box. Each of them typically have 8 GPUs within them. I think recently at I think it's NVIDIA's GTC, they just talked about, this new NVL 72 system where it's basically 72 GPU racks. That's a whole nother podcast conversation to talk about NVIDIA. But yeah, so to get that to come together, okay, I lost my train of thought thinking about NVL 72s because I was like, man, that's a rabbit. Well, repeat your question one more time, Lucky, so I can get back to it.
Just with Grok, XAI, the facility itself, it required, I don't know how many megawatts and the facility itself, what it would take to grow a facility like that now, because people just see Grok, right? They just see Grok, XAI, and then Grok's fantastic, from depending on who you ask, but to power and build a facility like that from ground up, I mean, there's what kind of insight do you have on things of that nature? Because for me, I'm on the application layer, and I don't really know, but you just hear in the news what type of a lift that was to do, and they did it in weeks and days.
Yeah, so typical deployment, I would say for a data center, right? We're talking about a data center. You're looking about a 12 to 16 month build, right? Whoever they contracted with built it faster. And then the second half of that is deploying the physical systems. I think they deploy like 100,000 GPUs. That industry average, you're looking at 6 to 12 months to deploy that much. I think they did it in like 100 days. So there was, I believe, like 1,000 of workers working 24-hour shifts overnight to pull that together. That's just not Twitter or X doing this. There's other companies that are doing this exact same thing where they're running 24/7 around the clock. Because right now it's kind of like the race to the moon. The faster, cost is not relevant to these individuals because there's billions and billions of dollars of cash and CapEx to throw at it. But the faster to the market is the people who will win. And I think that's why you're starting to see this race heat up between countries of who's going to be the dominant player and leader in AI.
Wow. Well, Bobby and Drew, what are your thoughts on hardware? Because we see it from, say, a brick and mortar kind of scenario, but closer you are to the data center, your experience changes a little bit, right? Depending on what it is that you're doing, and given your background, data latency is a huge problem that you guys are trying to solve. So, what are you guys' thought on what do you think about the hardware and the data side of things and the experiences that you guys have?
I'll defer to Drew.
Drew, you want to go?
Sure. Well, I mean, I'm gonna make some general statements related to what I'm seeing from I mostly work in the cloud neutral analytics data space that the Databricks works in, and you can. The short story is that the LLM revolution that's happening is probably still the most popular because the work that goes into building deep learning, it's not that it's not relevant, it's that there's been, I would say, kind of a plateau in innovation in what can be done. There's been a lot of work that comes out of that, but right now, being able to use large language models to be able to build AI agents to be able to take over tasks that either used to have humans or are doing things that humans can't do is kind of the next undiscovered country. And so, that's the hard part is that there's a spectrum of how much GPUs are needed in that in that work, because if you're lucky, you can do shortcuts to not have to use GPUs. But there's a lot of things that if you're building really big models like a Grok or like an XAI, where you need to have these types of infrastructure. So I'm going to stop there because I don't want to get too far down. So just wanted to say that.
Well, that's good. That's really, really, really insightful. I really appreciate that. From my experience, not only is everything really true, I think most people don't understand, again, the opportunity that's here when you learn basically the hardware piece of it. What we know is things happen and humans can only accept so much change, right? So when you talk about data centers and the types of processors, it's not the bleeding edge of what's possible. It is a new plateau as from a industry standpoint of how business models in that chip design world is going to operate. And for me, I learned that lesson early in my career. I used to work for a company called DEC. It's not here anymore. But DEC, now HP, part of HP, we had a chip called the Alpha chip, which was a RISC chip, and Intel was stuck in x86 land. Long story short, some people from DEC were hired on to Intel, and then that's when they came out with Xeon chips. But bottom line is when we looked at the chip, we was like, this is our stuff in here. Huge court case, and you think we're going to win. It's a slam dunk, and something like they didn't even change some stuff. And the judge rendered a landmark decision. He said, yes, they stole it flat out. That's what they did. And you are entitled to some type of compensation. But if I make Intel cease and desist making the chips that now are such a part of business in the world, I will break an industry, and we don't want to break an industry. So right now, if you take the opportunity to learn the latest of what's out there, variants of that will be around for a while. So it's not like you're learning something. With software, you learn it. Next version, you relearning it. Coding, with coding, you learn a language. I'm tired of learning languages, right? So I was glad with this latest iteration that it's low code, no code. But with the hardware, you got variations of whatever is out there. But as far as a huge leap forward, we've just had a huge leap. So if you learn what's out there, if you're not very tech savvy, or as he said earlier, if you don't like coding, but you do like earning money in the tech field, I think learning about the various hardwares that are out there and getting into that field and seizing that business opportunity will give you a strong financial foundation to then kind of get on the train and be on the what's next. But so much infrastructure has been built out with the current iteration of technology, they're not going to just dump that. So you have something that's not just relevant today from a sustainment standpoint, and then has to be maintained. All of the things, just like your car. You buy a great car, but you better have a great warranty, because without that great warranty, you will regret buying that great car. Are you that person who understands the technology, understands average mean time to failure, and what does that mean? What kind of things you need to keep on stock? Who do you need to partner with? I think it's a great opportunity for anyone who literally wants to get into the tech field without being super techie and without the technology kind of shifting under their feet super rapidly. What we found out already was great hardware, great software for models, and then a new software came out and said, I could do the same thing with less. Well, businesses like to make more money with less resources. Sounds like a winning kind of plan to me. What are y'all thoughts?
Well, I'm going to give it back to Masako because she started this whole fire here. But I think Masako has a mission that speaks to what has never changed. And I think this is another piece of the conversation that everybody should take away with, is that no matter how you see things in the world that is shifting, the sand that's always moving, one thing that hasn't changed ever is data. And I challenge myself to say that, right? Because data will always be here. It's just that one data that you never captured and the data that you did capture. That's the only data that's changing, right? If you haven't caught it, it's gone. But one that you caught it, it's there with you now. It's up to you to do what you're going to do with that data. So me and Masako was talking about like data at rest, data in motion, data in use, which means that these three states of data will never change. It's where you fit into that three pieces of data is where you're going to either find the AI hype or the semiconductor chips hype. And that will tell you what part of the spectrum you're in. Because if you're on that AI hype that everybody's talking about today in this, ever shifting user interface versus that AI that's happening on the chip side of things, right? But they all stay the same as long as they're data. So Masako has this great ambition of doing data literacy, and I'm going to talk. I'm gonna have Masako describe that data literacy program because I think no matter who you are, you just need to have some data literacy, and you'll feel like cool as a cucumber after that. Because otherwise, these stuff hits you up, man. This stuff is like so confusing, so much power draining. But hey, take it from data literacy. You will see the value in that. What do you say, Masako?
I absolutely agree with you, Asif. Data literacy, everything is data, right? And, my mission is speaking to the individuals that feel like they may be left out, that they don't understand what is happening in this tech space with semiconductors and AI. Here's the thing, though. You have to be at a state of curiosity for you to look deeper into what is next. What is my best next step in order for me to have success in this world? Because when it comes to data literacy, if you're not understanding where you are and what data means to you, everything about yourself, what is unique to you and your household, then you're not going to see that. It's so easy to just ask, okay, what are my best next steps to understand what is happening in this current climate? And if you are looking to continue to live in this current climate and you want to eat and you want to be a part of the have-mores versus just the haves, you have got to get curious about semiconductors and AI, because it's like the brain and the heart and the muscles. They go together. You cannot have one without the other. And you have to have a hunger and show up and just ask, okay, what is next? Where do I fit in this space?
Right.
Where can I go tomorrow in order to have longevity, to have a career and continue to thrive? Because if you don't, you're going to get left behind. And I always relate things to movies. And when I think about our current climate and I think about movies, I think about, you guys remember the Terminator? How the Terminator, they have the semiconductor chips within the Terminator, and that's how they're processing the information, and that's how they're moving extremely quick. And it's just like they're always on to the next thing before you can even fire your synapses to think about what you're going to do next. And so I think, as a person with blood flowing through your veins, you do not want to be the person that's left behind where you cannot even participate in the conversation. So it starts with data. What data do you need to know? You first need to know yourself, and then you need to get training, because you're going to find success when you leverage the knowledge that you have and you exchange your knowledge by placing value on that versus exchanging your time, because people don't place value on the time that you have. They place value on the knowledge that you leverage. That's my thoughts on it.
Yeah. And this all brings it to the same aspect that no matter how you want to engage anything that's happening today, if you don't have the data-driven decision mind, you have to start practicing, right? So, a lot of people say, like, I'm learning about data. I say you're learning to deploy data in the correct setting with the correct sort of data sets. It's all about data. So if you don't have that data mindset, you're going to fall for things that are presented to you using data, and you're going to use the data set that you don't use to make decisions on those bad data. And that is not necessarily just 5 years of events. This has happened for generations and decades and thousands of years, where we've been presented the wrong set of data, and that's how we made decisions based on the data that we didn't think we need, and we never deployed it. So I get really passionate discussing these topics because, as you can see, everybody here is talking about data. And we're talking about large language model, we're talking about cybersecurity, protecting those data, processing those data, architecturing those data, teaching about this data, right? And that's important because data is not something that we can just ignore as techie stuff anymore, right? data is literally part of our way of living today, because we're presented with so much data in a digital means, news cycle, movies. And, here, me, Lucky, and Bobby, we just love talking about movies. Oh, so many movies.
Well, the funny thing is just life imitates art. And if you don't get on board and get familiar with AI, it's going to catch you by surprise, kind of like Skynet did on Terminator. You got to be ready for the Terminators. You got to know where the off switch is. So in order to, and realistically, life does imitate art. And there's a lot of books, there's a lot of movies written, have been produced on artificial intelligence. And what our best way is just to prepare, understand what AI is and what it isn't. So we're not building that monster in our head to say AI is going to, come out of the closet and then take me out because I have something to do with AI in the future. And so if anything, start to figure out, where you fit. If it isn't designing AI models, we hit it right on the head earlier. There's a lot of, blue collar people that are out there that would benefit with working with AI. The electricians, that's something I would love to get into. Plumbing, what it takes to build a data center. There's a lot of moving parts there, not just AI is going to replace people. And I think we need to get rid of that stigma. It's more of a tool. Yes, there's a lot of functionality there that can help us do our jobs better, but we have to prepare ourselves. And what do we do? How do we do that? Do you like to work with your hands? Do you like to work with your mind? At the end, everyone has a piece of this AI, this new future in AI.
You know what, Lucky, I want to piggyback on you because you said the monster in the machine.
Mm-hmm.
If you do not participate and you come to leverage the knowledge that you have and sharpen your skill set on AI, then fast forward, you will find a monster in the machine, because what you'll find is more biased data and you will be excluded.
Mm-hmm.
So history will repeat itself in such a heinous way that you're not even included in the landscape of what is happening. Could you imagine not being included? Like, you'll be wiped off the face of the earth. You will not even have a legacy to continue. You'll say, oh my goodness, I remember when, but you won't be a part of it. So that alone is reason for you to just like, I got to be curious about this. I have to become one with this, because without you and your input, then you're written off.
Yeah,